Alright, as promised, this is the limiting reactant example. This is actually problem 3.85 from the book. So we're reacting hydrogen sulfide with molecular oxygen to give us elemental sulfur, S8, and water. And this reaction actually occurs at a fairly elevated temperature, which is why the elemental sulfur is liquid and everything else is a gas. Now the first thing I usually do with some of these problems is just figure out the molar mass of everything and just maybe write them above each compound. So that's what those numbers are. So for example, the molar mass of H2S you should be able to calculate is 34.08 grams per mole. Now, the problem gave you the masses of both the H2S, and it said you had 30 grams of this, and 50 grams of the oxygen. Now, whenever you're explicitly given the mass of both reactants, then that's kind of a red flag that says you need to figure out which is going to run out first. What's the limiting reactant? And remember, things react mole to mole, so it is definitely not for sure the thing that is present in the lowest mass. Things react mole to mole, so the next thing would be to actually calculate the amounts that you have of both of these. And you do that with the molar masses. So the molar mass of H2S is 34.08 grams per mole. So that 30 grams of H2S corresponds to 0.88 moles of the hydrogen sulfide. And likewise, that 50 grams of water corresponds to 1.56 moles. Now, even that's not enough because these things don't react one-to-one. So to really figure out what the limiting reactant is, you need to determine the number of equivalents of both of these reactants. And you get the number of equivalents simply by dividing the amount of that component by its coefficient in the equation. So, for example, that 0.88 moles of hydrogen sulfide corresponds to 0.110 equivalents of the H2S, and we have 0.39 equivalents of the molecular oxygen. Now, the one with the fewer number of equivalents is for sure your limiting reactant. One way to think about this is enough H2S to run the reaction 0.11 mole times, and this is enough oxygen to run the reaction 0.39 mole times. So the H2S is going to run out first. So once you make that determination, number one, forget you ever heard about equivalents, and remember that you need to base all of the stoichiometric calculations from here on in with the amount of the limiting reactant as your starting point. And from here on in, it's pretty much the way that we've been doing for the past couple of days. So we've got our 0.88 moles of H2S. The equation tells us that we're going to produce 1 mole of S8 for every 8 moles of H2S that we react. And also that we've already calculated that each mole of S8 that is produced has a mass of 256.52 grams. And if we punch all that through, we can expect the production of 28.2 grams of S8. Now, this is the theoretical yield. This is the maximum you could expect to find. And the problem is stated that what would you get assuming a 98% yield? So that's pretty straightforward. We're just going to get 98% of that. 27.6 grams of SA. And that's it.